Hi everyone, this video tutorial is to cover some of the basic geometry vocabulary. So for instance, a point, okay, notice that this is a point and you have a capital A, and that's how we denote a point. Also, points are the most basic concepts in geometry. That's where every concept in geometry starts, okay, so points are very important. So for instance, a point is an undefined term. A point represents a location. Okay, each point has a unique location. Points have no size at all. That means we cannot measure points. Points are fixed and we cannot move points. And we draw a dot just like you saw here to denote a point. And we name a point with a single capital letter. So in this case, this point is point A. Now when it comes to a line, let's say this is point J and this is point A and this is lowercase m. This line we can name J A or A J, and notice on top this arrow, this two arrows on the end means it's a line. Or we can also name this line M by this lowercase m here. Okay, so a line is also just like the point, an undefined term. And a line is a series of points that go in opposite directions forever and ever. Okay, so this is, let's say this is our line AJ, and a line has infinitely many points, so it contains all those points. Okay. Now a plane. Let me just point out that we have a letter Q, and this is a plane. This is a plane, and we have 3 points. So let's name those points. Let's call this one X, this one Y, and this one here point Z. So we can name this plane X, Y, Z, and also plane Q. Plane. Planes are also, well, plane is also an undefined term, just like lines and points, and it's a flat surface extending in all directions forever and ever. Think of your desk, or maybe your table. You know, if you have your notebook in front of you, and maybe it's laying on top of a table, that's kind of a plane, just so that you can visualize it. A segment. So let's again call this point G and this point O, and a segment is a piece of a line. So our segment GO is a piece of a line. It has 2 endpoints and no points in between. There's a big difference between a line and a segment. So let's say again this is segment GO, and I'm going to extend this in both directions, and I know that's kind of crooked, but I hope you get the idea. This line contains segment GO. Okay, all segment GO contains are the points in between its 2 endpoints. When it comes to array, let's say for instance this is the endpoint U, and this is P, a point somewhere here. Okay, so this ray goes from U to P. Now ways of naming this ray are U, P, and this is the symbol for ray. And notice that the symbol says that we go from U in the direction of P, and that's the only way we can name this ray. you might be tempted to call this ray P U, but what you're saying here is that P is the endpoint and it goes in the direction of U. That is not true, so we cannot call this ray PU. It's only UP. Okay, that's very important. Don't forget that. So as you saw, UP is the name of a ray, and a ray is a piece of a line. Again, it has one endpoint and all points extending in one direction. In this case, going from the endpoint U to point P. We have infinitely many points. An angle. So let's say this is A, Z, and let's say this is P. So for instance, we can name this angle. Before we name the angle, let me just point out that an angle is formed. This is, I hope you realize, this is a ray. So this is ray AZ, and this one here is ray AP. So it goes from A in the direction of P, and this one goes from A in the direction of Z. Now they intersect at this point, and this point is called the vertex. Okay, now let's name this angle. Angle naming. Let me just say that this symbol means angle, so when you start seeing this, that's the symbol for angle. So we can name this angle angle ZAP, angle PAZ, angle A, and angle 1. Okay, let me just point to you. So if we're going to use this one, we're saying that we're going from ZAP, and this one we're going from PAZ. Okay, now for this one is the vertex letter. So you can also name an angle just by the vertex. Angle 1, that's this one here, the number inside the angle. Something that I want to point out, notice that if you're going to use 3 letters, the vertex letter always goes in the middle of the 3 letters, okay? Because that's the vertex. That's why that letter has to always go in the middle. You cannot call this angle AZP. That is not true because Z is not the vertex. A is the vertex. So keep that in mind. So when it comes to an angle is formed by 2 rays that share a common endpoint. The vertex, in this case, that was the letter A, that was the vertex, okay? Now, collinear. Collinear means we have 4 points here and they all lie on the same line. So that makes those 4 points collinear. Collinear points are points that lie on the same straight line. Coplanar. This is again a plane, and we can have points that are coplanar, rays that are coplanar, lines that are coplanar, and segments that are coplanar. So as I said before, we can have coplanar points, coplanar lines, coplanar segments, and coplanar rays. And what that means is that they lie on the same plane. Acute angle is an angle that is less than 90 degrees. An obtuse angle is an angle that is greater than 90 degrees. A right angle is an angle that equals exactly 90 degrees. A straight angle is an angle, and notice that it's just a line, looks like a line, but we're saying it's an angle. A straight angle equals exactly 180 degrees. Acute, less than 90. Obtuse, greater than 90. Right, exactly 90 degrees. Straight angle, exactly 180 degrees. Parallel lines. Let's say this is line A, B, and this is line CD. Okay, parallel lines will never intersect. So, and this is this here. Well, these two arrows in the middle, kind of in the middle of these two lines, means that the two lines are parallel. So this symbol here, this one here means parallel. Okay, this is notation. And parallel lines are lines, two lines that run in the same direction and never intersect. Now you can have many lines that are parallel. It's not only two, okay, but usually we use two in geometry, but you can have many lines that are parallel and they will never intersect each other. Perpendicular lines. Perpendicular lines, when they intersect, they create this right angle. So for instance, this symbol here, let me do that again. This symbol means perpendicular. Okay, and perpendicular lines are two lines that intersect and form right angles, as you saw in the picture. And this one here is for skew lines. Okay, and let me just point this out to you real quick. This line and this line are skew, and what makes them skew is that they lie on different planes. These two lines cannot be parallel and they cannot be perpendicular. Okay, well, they are not parallel, that's all you need to know. And they will never intersect each other because they lie on different planes. This line lies on this plane, this one here lies on this plane, and I think I'm going to give you a visual in class for that so you can kind of understand it better. So skew lines are two lines that are not parallel and do not intersect. Adjacent angles. Adjacent means next to. Okay, that's what it means to be adjacent. So in this case, angle 1 and angle 2 are adjacent to each other, so that means they're next to each other. So adjacent angles means two angles that share a common side and vertex. So let me redraw the picture. Let's say, for instance, this is angle 1 and this is angle 2. They have this side in common, okay, and they have this vertex in common. And that's what this is saying. Two angles that share a common side, so that's this one, and a vertex. This is the vertex. So they are next to each other. Angle bisector. Let me point out to you the angle bisector, and that's this one here. It's a ray that bisects an angle. Bisector means that it's going to cut this angle into two equal parts. This arc here and this arc here means that angle 1 and angle 2 are congruent, okay, or they're equal to each other. As I said, angle 1 is congruent to angle 2, or angle 1 is equal to angle 2. So an angle bisector is a ray that divides an angle into two congruent angles, in this case, angles that are equal. The last one I'm going to go over in this tutorial. In this tutorial is, for instance, let's say this is point L, this is point N, and this is the midpoint M. Okay. Now what the midpoint does to the segment is that it cuts it in half. Once we introduce the midpoint, this segment LM is equal or congruent to segment MN, and that's what these symbols here represent. This one is equal to this one. Okay, so let me just kind of cover this here, because this is not true. This is the symbol for a line and it's not a line. These are segments, and that was a typo. I apologize. So this is segment LM and this is segment MN. And this is saying that they are congruent, or LM is equal to MN. So the midpoint is, the definition of a midpoint is a point that divides a segment into two congruent or equal segments. Okay, and that's all for now. I hope you guys understand this. If you don't worry. I'll answer any questions you might have tomorrow. Sleep well, and look forward to see you tomorrow. Bye-bye.